Good morning, one and all. So today we are going to discuss about the classification of the signals. So yesterday we completed half part of the classification of signals. Today we'll again continue the classification of signals. Myself is Vijay Shankar from the EC Department, Chipol Engineering College. In yesterday's class, we discussed about the classification of signals. The classification of signals are in that analog signals and the digital signals. Analog and the digital. And analog is continuous time signals and digital is a discrete time signals. Okay. Again, these continuous time signals and the discrete time signals classified as periodic, non-periodic. Periodic and non-periodic. Then even and odd, deterministic and random signals, energy and power signals. What is a continuous? Again, I'm saying that what is a continuous signals? Both the amplitude and time, both are continuous. Then we can call it as a continuous time signals. Discrete time signals, time is discrete and amplitude is a continuous, then we can call it as a discrete time signals. And what is a digital signals? Digital signals are both time, nothing but in the x-axis, and amplitude, nothing but in the y-axis. Both are discrete. Then we can call it as a digital signals. Analog circuits process the continuous time signals. Digital circuits process digital signals. We already discussed the examples also, such as analog circuits or operational amplifiers, filters, and amplifiers, etc. And digital circuits process the digital signals, such as microprocessors, counters, and the flip-flops, etc. Okay. And yesterday class, we already discussed about the periodic and non-periodic signals for both the continuous and the discrete. So what is a condition for the periodic function in the continuous time signal? A signal is said to be periodic if it repeats at regular intervals. Periodic signal is nothing but a signal is said to be periodic if it repeats at regular intervals. At regular intervals with a period of t, capital T, as continuous time signal, and capital N is for the discrete time signals. So the condition for x of t is called a periodic if and only if x of t plus capital T is equal to x of t. Even we can add the t, capital T, a fundamental period, to the signal x of t plus t is the same as the signal x of t for all the values of t. T is symbol for the continuous only. And N is a symbol for the discrete time signal. Okay. So what is that condition for the periodic signal for the discrete time signal? X of N plus capital N. X of N plus capital N is equal to x of N. Even the fundamental period N is added to the signal, we'll get the x of n, then it is a periodic signal. It is repeats at regular intervals. For continuous, it is a t. For discrete, it is a n. Okay. You can see the angular frequency in the discrete time signal and the analog signal, or the angular frequencies, the t is equal to capital T is equal to 2 pi by omega. And here also the same, n is equal to 2 pi by omega. The symbol is a different for continuous and the discrete time signal to find out the fundamental period of t for continuous, fundamental period of n for discrete time signal. Denominator is angular frequency only, the 2 pi by omega, the 2 pi by omega, and here also the 2 pi by omega only, but the symbol for continuous and discrete is both are the difference. Okay, and here the sum note we have the sum of two continuous time periods or may not be a period, and the sum of two periodic sequences. Periodic sequences means for discrete time signal. For discrete time signals are always a periodic. The sum of two periodic sequences is always a periodic. And the third one we have the sum of two periodic signals is a periodic only if the ratio of their respective periods is a rational number. For continuous, you can take as a ratio between of the two signals. For x1 of t, the time period, the fundamental period is t1.
Hi.
And the second signal, fundamental period is a t2. The ratio between the t1 and the t2 is a rational number. Is a rational number. Then only it is a periodic signal. Okay. And the fundamental period is a LCM. The period is a LCM, the least common multiplier of the t1 and the t2 of the two signals. If the ratio of t1 and by the t2 is an irrational number, then the signals x1 of t and x2 of t do not have a common period. Do not have a common period. When only we get the ratio between of the two fundamental periods of the given signals, it is a rational number. There is a common period we have, and it is not the rational, it is an irrational number, and we don't have any common period of the two signals what they given. Okay, these are some graphical representations of the signals x of t as a sinusoidal is repeated for the particular interval of time. It repeats for 0 to t, t to t means for every fundamental period of t, the sawtooth is repeats. And here also the sinusoidal signal for every full cycle, it is repeats the signal. We can call it as a periodic signal. And here the x of n is also for every 4 samples, it is repeats is a signal. Okay. Then coming to non-periodic signals, so see the non-periodic signals, it is not repeated after the t here and before the minus t. So it is a 0 before the minus t, and after the t is also 0. If it is not repeated, we can say this is a periodic signal, is a non-periodic signal. Means it is not satisfy the signal of x of t plus capital T is equal to x of t. It is not equal to x of t, then we can call it as a non-periodic signal. And second characteristics also you can see here, a right triangle wave from the minus t to the below and t to the above values. There is no any repeating of the triangle signal from minus t to the t. It's a 0 values. Okay, it's a 0 values here. So it is also a non-periodic signal. Then coming to here, this is a delta of n, nothing but impulse signal. Impulse signal will get it to only the n is equal to 0. is a discrete function. X of n is equal to delta of n is nothing but impulse signal, and minus values and the positive values, all the values of the zeros except at 0 is equal, n is equal to 0. Except at n is equal to 0, the remaining all the values is a 0. So here also it is not repeating the signal with the particular intervals. So these three characteristics shows a non-periodic signals. And coming to the second classification of discrete and digital, or the discrete time signal and the continuous time signals, even and odd signal. What is a even? So example is a cosine function. For negative values also, the amplitude is a positive. For negative values of time signals, once again you can listen carefully, my dear students. We are taking the negative values of time, x of minus t is equal to x of t. X of t is amplitude signal. For negative values of time, the amplitude is positive for negative values also, then it is an even signal. A signal x of t or x of n. X of t is continuous, x of n is a discrete. Is said to be even signal if it satisfies the condition of x of minus t is equal to x of t for all the values of t. And for discrete, x of minus n is equal to x of n for all the values of n. Only difference is the variable. T for continuous, we are using for continuous, and n we are using for discrete one. Okay, don't confuse here. And the signal x of t or x of n is said to be odd signal. Odd signal if it satisfies the condition x of minus t is equal to minus x of t. For negative values of time function, we'll get negative values of amplitude, x of negative values of the signals for all the values of t or for all values of n. That signal, call it as odd signals. Okay, what is the example of even cosine signal? Even cosine signals are symmetrical and odd signals are asymmetric. Symmetrics are cosine functions, so those are even signals. Asymmetric or odd signals, those are sine signals. Okay. And here I'm taking a signal x of t and x of n can be expressed as sum of two signals. Sum of two signals. X of t is equal to having two terms. One term is even signal and another term is odd signal. One odd and one even. First term you see x e of t, the even part. X o of t, odd part. Okay. As in the continuous time signal, x of n, as in the discrete time signal, x of n is equal to x e of n plus x o of. From these two, we can write it as an even part and the odd part. By adding, we get the even part. By subtracting, we get the odd part. Let how can see. I will explain the board. You see here. I'm taking the x of t. X of t is equal to half part, nothing but an even signal, x e of t. Okay, x e of t plus
ఎవరండి జరుగుతుంది ఆన్లైన్ క్లాసులు ఉన్నాయి ఆన్లైన్ చెప్తున్నారు సెకండ్ ఇయర్ చెప్తున్నారు ఏది వచ్చింది ఒకటేమో
హర్ష 456 మ్యూట్ యువర్ హర్ష 456 x of t is equal to x e of t plus okay. So board is not proper there. So x of t is equal to x e of t plus x o of t and x of minus t. Take the second equation by substituting the t is equal to minus t. X of minus t is equal to x e of minus t plus x o of minus t. But even function x e of minus t becomes x e of t. X o of minus t becomes minus x o of t since it is an odd function. For x of minus t, the equation is x e of t minus x o of t. X e of t minus x o of t. Then you can add the two functions x of t minus, not the minus, it is a plus, x of t plus x of minus t is equal to x of t plus x of minus t is equal to, what is x of t? X e of t plus x o of t plus, what is x of minus t? X e of t minus x o of t. Okay, so the even functions are the 2 into x e of t and plus x o of t minus x o of t get cancelled. 2 x e of t is equal to x of t plus x of minus t. Taking off x e of t is equal to 1 by 2 by taking the cross multiplication. 1 by 2 x of t plus x of minus t. This is the third equation here, as you can see. Similarly, subtracting the x of t and x of minus t, subtracting the x of t and x of minus t, x of t is x e of t plus x o of t and x of minus t is x e of t minus x o of t, subtracting the cancelling of the even parts, x e of t and x e of t, and we have the 2 x o of t. So 2 x o of t is equal to x of t minus x of minus t. So x o of t is equal to 1 by 2 into x of t minus x of minus t, the even part and the odd part. Okay, the same way it can be represented in the discrete function also. The discrete means only the change of the t as n. So x e of n is equal to 1 by 2 x of n plus x of minus n as an even part. X o of n is equal to 1 by 2 x of n minus of x of minus n. Okay, so the product of two even and odd functions, the product means the product of two even and odd signals is an even signal. Is an even signal, and product of an even signal and odd signal is a odd signal. So minus into, I told the minus into minus and the minus into plus and the plus into minus and the plus into plus. So minus into minus and the plus into plus, will get the plus here into the, we'll get it in the multiplication, it's a plus only, and plus into minus or the minus into plus will get the minus values. Okay, see the even signals here. Even signal is a cosine signals, not the cosine signal, and odd signal is a cosine sine signals. Okay, odd signal, here is the positive and here the negative, and here the positive and here the negative values, and both sides will get the same thing. For the 0 to t or the 0 to minus t, we'll call it as a even signals. For the minus signal and the plus signal, both is the same. For both, the x of t is the same. For odd signal, for 0 to t, for the positive value, not the t here, the pi, 0 to pi, for 0 to pi is a positive value, and 0 to minus pi, it shows is the negative. Why? It is an odd signal. But even signal means for x of t is x of t, x of minus t is also x of t. For negative values of t and for positive values of t, both the same of x of t. You see here is a signal 0 to some value here, showing that in the positive only, and the 0 to minus values also, it shows the same signal, and in the sinusoidal signal also here. Next, coming to the deterministic and random signals. What is a deterministic and what is a random signal? See the definition there. A deterministic signal is one where no uncertainty occurs with the value of any time. With respect to its value, at any time there is no uncertainties. For there is no any uncertainties, we can call it as a deterministic signals. Opposite to that, a random signal. What is a random signal? A random signal is one about which there is some degree of uncertainty. Degree of uncertainty before it actually occurs. So the example is a TV and a radio receivers when we can tune to the frequency where there is no any broadcasting. Okay, deterministic means there is no any uncertainties occurs with respect to the value at any time, and if some degree of uncertainties occurs, we can call it as a random signal. Example, the x of t is equal to sine 50 into t as a continuous, x of n is equal to 100 into sine 50 n. Okay, which having the uncertainty, we can call it as a random signal. Where there is no any uncertainty occurs with respect to the time, we can call it as a deterministic signal. Mathematically represented deterministic, mathematically it is not represented the random signal. Okay, and coming to the real and the complex signals. A real signal, which is totally the magnitude, not having any imaginary function. X of t is a real if its value is a real number and is a complex signal. If its value is a complex number, combining of real and imaginary terms, call it as a complex. Okay, in that, you see the example I wrote there, the x of t is equal to x1 of t. x1 of t is a real term, and x2 of t is also the real term. When there is a j is there, that is a imaginary part. imaginary coefficient, simply you can say the imaginary coefficient. Combining of the two signals, x1 of t plus j into x2 of t, we can call it as a complex number. Understood? With j square is equal to -1, we know, and j is equal to under root of -1. And the last one, the classification of signals, we completed the periodic, non-periodic, even and odd signals, deterministic and random signals, real and complex signals, and the last one is the energy and power signal. So everybody know what is the power? P is equal to, in terms of the voltage and the current, as we discussing in terms of the signals. So the power representing of P of t, voltage is V of t as a signal, voltage signal with respect to the time, and power is P of t, and current is also I of t. We know the P is equal to I square R, or P is equal to V square by R. The voltage and the resistance, V is equal to IR. Like that, the power will get I square into R, V is into R. So V square by R in terms of the voltage, and I square into R in terms of the current, the power. Okay, we can take the current resistance is 1 ohms. What is the power signal? P of t is equal to V square of t, nothing but the square of the voltage signal. In similar way, the square of the current signal also, when that resistance is 1 ohms. If the resistance is 1 ohms, in terms of voltage, the resistance in the denominator, in terms of the current, the resistance is in the multiplication factor. When I'm taking the resistance 1 ohms, the power P of t is equal to square of the voltage signal and square of the current signal. Okay. In general, the signal means we always taking the f of t, x of t like that. So in x of t, in general, x of t, whether it is a voltage or the current, whatever it is, x of t is equal to the voltage, or x of t is equal to current. Modifying the function, previously the P of t is equal to V square of t or I square of t, whether it is the current or the voltage, whatever it is, let it be the x of t. X of t is equal to V of t, that is equal to I of t. So the power P of t is equal to x square of t. The power P of t, the power signal, not the power signal P of t is equal to x square of t. That x square of t will get from the voltage or the current when the resistance is equal to 1 ohm. The total energy or the normalized energy, we already know the energy signal E is equal to integral minus infinite to infinite x square of t dt. Or with the finite duration, the t1 to t2 x square of t dt. You see here, the last in this slide, the last equation, energy is equal to, why I'm using here the integration? Integration is for continuous time signal, and the summation can use for discrete time signal. I use x of t, so it is an integral of minus infinite to infinite, a finite duration, minus infinite to infinite x square of t dt, or if it is a limit t tends to infinite, we can take the finite duration is from minus t by 2 to the t by 2. If this t by 2 to the t by 2 changes of minus t to t, we can multiply the 1 by t. Remember, my dear students, in some there we are using the integral minus t to t, capital T to the capital T, minus t, and the upper limit is plus t. In that case, the limit t tends to infinite, 1 by t is also there. When we are removing that t, we can change the limitations as minus t by 2 to the t by 2. Okay. The normalized energy in limitations, limit t tends to infinite, the integral minus t by 2 to the t by 2, x square of t dt, or E is equal to integral minus infinite to infinite x square of t dt is the energy signal. The energy signal is varies from the 0 to infinite. We can call it as an energy signal. In that case, the power is infinite. If the power signal is a power signal, in that the energy signal is a 0. Okay, that we can see in the next slide. You see here. Next one, the power. The average power or the normalized average power P in continuous time signal. You see the P is equal to whatever the energy signal is there, that only we are taking. The limit t tends to infinite 1 by t. Now here this is a power, not the energy signal. It is a power 1 by t, the integral minus t by to the t by 2 x square of t dt as a continuous time signal. For see the discrete time signal is changes in terms of the integral there. Here the sum of energy is sum of n is equal to minus infinite to infinite and square magnitude of x of n. And for the power, limit n tends to infinite 1 by 2n plus 1. 2n plus 1, the sum of n is equal to minus infinite, not the minus infinite, minus n to n, the squared magnitude of x of n. These are the formulas for the energy and the power signals in continuous and discrete time signals. See the note there, when we can call it as a power signal and when we can call it as a energy signal in the relation between of power and energy. First, you can see the signals for which total energy is finite. The total energy is finite. So E is equal to 0 to infinite, in between of 0 to infinite, not equal to. Okay. 0 less than E less than infinite means it is greater than the 0. E is greater than the 0. And E is less than the infinite, means in between of a 0 to infinite, are called energy signals. In that case, they have 0 average power. The power is equal to 0 and energy is in between of 0 to infinite. We can call it as an energy signal. Okay. The examples are deterministic, and that signal is a non-periodic signal. It is a deterministic and there is no any uncertainty in that, and it is a non-periodic signal. Coming to the power signal, when we can call it as a power signal, the signal for which the average power is finite, means power is also in between of 0 to infinite. It is not equal to 0 and not equal to infinite. In between of 0 to infinite, the power is greater than the 0 and less than the infinite, nothing but it is a finite value. In that case, the energy is infinite. Okay, average power is finite, the energy is infinite, then we can call it as the power signal. And energy is finite in between 0 to infinite, and the power is a 0 there. The power is 0, then we can call it as energy signal. And the power signal when the energy is infinite. It's a very, very important bit. It is 2 bits we have. Okay, the both energy and the power signals are mutually exclusive. Let's do it. Mutually exclusive. So with this, the classification of signals is completed. Periodic, non-periodic, for continuous and discrete. The condition is x of t plus capital T is equal to x of t plus capital E, not the t, x of n plus capital N is equal to x of n. The condition for periodic, if this condition is not satisfied, then we can call it as a non-periodic signal. And even and odd signals, second one. The even signal, cosine function, odd signal, sine function, is an even part in continuous, x e of t is equal to 1 by 2 x of t plus x of minus t and odd part is xo of t is equal to 1 by 2 x of t minus x of minus t. Similar way for discrete time signals also for x of n and x o of n. Coming to the third one, deterministic and random signal. Deterministic signal is simply, we can say, it is represented in the mathematical expression, and there is no any uncertainty with respect to the values of at any time, and there is some degree of uncertainty occurs. We can call it as a random signal. Okay, even, not the even, the real and the complex function. If we have the two signals, real signal x1 of t and x2 of t, the complex number or the complex function x of t is equal to x1 of t plus j into x2 of t. Then it becomes of complex function. And the last one is power signal and energy signal. What is energy signal? The energy is in the power only. Okay, the power is equal to having, you see, the limit t tends to infinite 1 by t. The function, the total function is energy signal. E is equal to integral minus infinite to infinite x square of t dt, or p is equal to limit t tends to infinite 1 by t, the integral minus t by to the t by 2 x square of t dt, as in continuous. For discrete time function, the energy signal sum of n is equal to minus infinite to infinite squared magnitude of x of n, and the power p is equal to limit n tends to infinite 1 by 2n plus 1. 1 by 2n plus 1, the sum of n is equal to minus infinite to infinite, not the infinite, minus n to n x of n square. Okay, when we can call it as a total energy signal, the signal for which the total energy is finite is called energy signal. They have zero average power. And the signal for which the average power is finite are called power signals. They have infinite energy. Example is a random and periodic. For energy signal is a deterministic and non-periodic signals. And next one, next topic you can go, that is elementary signals. Elementary signals, the actual signals and system in graphical representation. In the graphical representation, how we can represent the graphical representations for the given any sequences. Any sequences. Let us see. You see here the representation of discrete time signals. In general, signals may be continuous time signals or discrete time signals. Continuous time signals are defined for all instants of time, whereas discrete time signals are defined only at discrete instants of time, particular instants of time. Continuous time signals are represented by x of t, and discrete time signals are represented by x of n, where t and n are independent variables in time domain. The continuous time signals are represented by a function or a graph. There are 4 ways of representing the discrete time signals. They are graphical representation, tabular representation, functional representation, and sequence representation. Okay, how we can represent any signal? If any signal is given, either it is a continuous or it is a discrete function. Now I'm showing here it is a graphical representation, functional representation, tabular representation, and the sequence representation of the digital signals. You see here, graphical representation. Considered a signal x of n. X of n means it is a discrete with values. X of -2 is -3. X of -2 is equal to -3, x of -1 is equal to -2, and x of 0 is equal to 0, x of 1 is equal to 3, x of 1 is equal to 3, and x of 2 is equal to 1, and x of 3 is equal to 2. The graphical representation, see the x-axis taken as the n values, y-axis is the x of n. What is the value of x of 0 or x of n at n is equal to 0? At n is equal to 0, the value is a 0 here. And at n is equal to 1, what is x? N is equal to 1 means x of 1 is equal to 3. You see here the 3. At 0, there is a 0. At 1, the x of 1 value is a 3. And at 2, the x of n value is 1. And at 3, the x of n value is a 2. The positive values, whatever they given. And for the negative values, you can see x of -1 and x of -2. Means at n is equal to -1, at n is equal to -1, the x of n is equal to 2. And at n is equal to 2, n is equal to 2, the x of n is -3. Is a graphical representation. Discrete time, graphical representation of a discrete time signal. Coming to the functional representation, simply write it as a function. When n is equal to 0 or for n is equal to 0, the value is 0. For n is equal to -1, the value is 2. For n is equal to -2, the value is -3. For n is equal to 1, the value is 3. N is equal to 2, the value is 1. For n is equal to 3, the value is 2 of x of n. Okay. And tabulation method, take the 2 rows and the columns as per the given. So minus values -2, -1, 0, 1, 2, and 3. For n values, n is equal to -2. What is the x of n? -3. For n is equal to -1, the x of n is a 2. N is equal to 0, the x of n is a 0. When n is equal to 1, the x of n is a 3. N is equal to 2, the x of n is a 1. And n is equal to 3, the x of n is equal to 2. In this way, we can represent the tabulation. Take the 2 rows, the values of n in the first row, and the values of x of n in the second row. According to the values of n, the x of n values you have to given them in the column wise. And coming to the last one, the sequence representation. sequence representation is only the importance. Further, in the second and the third units, we can go for the sequence representation or the tabulation representation only mostly. So here the arrow mark is represented in the parenthesis, a braces we are using for x of n. When the arrow mark is given here means that is the value of x of n when n is equal to 0. When the arrow mark is given in the sequence, that value is at n is equal to 0. Okay, at n is equal to 0, the x of n value is a 0. At n is equal to 1 in the right hand side, x of n value is a 3. At n is equal to 2, the x of n value is 1. N is equal to 3, the x of n value is a 2. And for left hand side, at n is equal to minus 1, the x of n is a 2. At n is equal to minus 2, the x of n value is a minus 3. And so on like this. If suppose in the sequence there is no any arrow mark. If there is no any arrow mark is given means the first value whatever we have. You see in the last line, the represented as x of n is a 3, 5, 2, 1, 4, 7. So here there is no any arrow mark is represented. If there is no any arrow mark represented means whatever the first value we have, that is n is equal to 0. Means there is no any negative values. N is equal to 0, the x of n is a 3. N is equal to 1, the x of n is a 5. N is equal to 2, the x of n is a 2, and so on. Okay, my dear students. In the sequence, the arrow mark is represented means that value is at n is equal to 0. In the sequence, there is no any arrow mark. The first value is at n is equal to 0. The first value is the x of n value at n is equal to 0. If arrow mark is given means right hand side is a positive values, left hand side is a negative values. No arrow mark is represented means it is started at n is equal to 0 towards the left right hand side the positive values only. There is no any negative values means all the negative values are zeros. Understood? In this way, the 4 ways we can represent the discrete time signal: graphical representation, functional representation, tabular representation, and sequence representation. Coming to the elementary signals, it's a very, very important. Elementary signals. What are the elementary signals we have? Unit step, unit ramp, unit parabolic, unit impulse, sinusoidal function, exponential function. One is real and another one is a complex. So totally the 7 elementary signals we have. And another one is also one elementary signal is there, that is a signum function that we can discuss in the later. The elementary signals, there are several elementary signals which play a vital role in the study of signals. Study of signals and the systems. These elementary signals are serves as a basic building blocks. A basic building blocks for the construction of more complex signals. In fact, these elementary signals may be used to model a large number of physical signals which occur in nature. These elementary signals are also called as standard signals. In the exam, if they ask, briefly explain the standard signals means elementary signals only. Or the list out the elementary signals or list out the standard signals means these are the 7 other standard signals. Step, ramp, parabolic, impulse, sinusoidal, complex function as a real and the complex, not the complex, exponential function as a real and complex. Coming to the first one, unit step function. Step. Step is nothing but is only we'll get for positive values. A step function is an important signal used for analysis of many systems. The step function is that a type of elementary function which exists only for positive time. You see here. A step function is an important signal which used for analysis of many systems. The step function is the type of elementary function which exists only for positive time and is 0 for negative time. This is a very important. This definition means the step function is that a type of elementary function which exists only for positive time, only and is 0 for negative time. Okay, it is equivalent to apply a signal whose amplitude suddenly changes and remains constant forever after application. You see, only you have to remember this one. The definition is the step function is that type of elementary function which exists only for positive time and is 0 for negative time. What is the equation here? The U of t. Step means we can represent it as U of t, unit step function. U of t is equal to 1 for values of positive, for t is greater than or equal to 0 is also taken as a positive. Mu of t is equal to 1 for t greater than or equal to 0 and 0 for t less than the 0. For negative values is a 0, positive values are 1. Having only the positive values, that magnitude is equal to 1 always. Okay, if a step function has unity magnitude, then it is called unit step function. Unity magnitude, the value is 1, then it is called unit step function. Okay, suppose if this signal is shifted towards the right side, means delay function, delay is nothing but actually, I will give some example. Our college will start at 9 o'clock, means at t is equal to 0 here, at t is equal to 0. But there is a delay occurs when the students are coming to the class with a delay of 20 minutes, with a delay of 10 minutes like this. That we can call it as a delay function. If suppose some of the students, they are early than our college time, means advanced signal. Actually, it is a 9 o'clock is our college time. They arrive at the college at 8:30 only, because means they are advanced of 30 minutes. And some of the students will arrive at the college with a delay of 30 minutes. Means actual time is a 9, advance means 8:30, delay means 9:30, with the 30 minutes of advance and 30 minutes of delay. Delay means is a subtraction. What is the delay here? See, the mu of t minus a, minus is represented as a delay. Actual time is t and it is delay with 30 degrees, that a, nothing but totally will get it is a 30 minutes delay. And is shifted towards right side. Actually, it's a 9 o'clock. They came, he or she, at 9:30. Means a delay towards the right side, moves towards right side. And advance means origin we can assume as a reference. Advanced means towards the left side. 8:30 is towards left side. 9:30 is towards right side. Okay. When this signal is shifted towards the right side means delay signal. And with the reference at origin, with the signal is moves towards left side is advanced signal. See the change of mathematical expression, the magnitude is the same. But what is the range here? The t is greater than or equal to a. Before that it is a 0. Now there is a delay occurs at t minus a. At that the amplitude is not changing, only the time is changes. And for the t is greater than or equal to a and 0 for t is less than a. Even the reference value is also 0 now. Okay. See that graphical representation is a mathematical representation, nothing but functional representation, graphical representation. It's a very, very important. See here. The step function for positive values only with the magnitude of 1, mu of t. See the B, the figure B showing that there is a delay is there. Actually you have to get at the 0, but it is get at the A. With the delay of A sample, it is shifted the total function towards the right side. Okay. If suppose it is towards left side, means advanced signal. Okay. Similar way, in the discrete time function, mu of n instead of mu of t, you can write as n. That is a discrete. Mu of n is equal to 1 for n is greater than or equal to 0 and 0 for n is less than 0. And shifting of k samples, mu of n minus k is equal to 1 for n is greater than or equal to k and 0 for n is less than the k. Okay, only the variation, the variable instead of n, instead of t, we are using the n. But graphical representation is changes. Continuous means for every instant of time. Discrete means at particular instant of time. The value is at 0, 1, value 1, the 1, n is equal to 2, the value, magnitude is 1, n is equal to 3, the magnitude is 1. So we are not bothering about the in between of 0 to 1. We are taking only at instant of times, a particular instant of time only. See, this is the first diagram, graphical representation showing that unit step function without any delay. The magnitude is 1 for instant of times 0, 1, 2, 3 and so on. Minus 1 is a 0, minus 2 is a 0, minus 3 is also 0. But here you can see it is shifted with the k samples. With the k samples. What is a k here? Whatever it is. You can assume k is equal to 1, k is equal to 2, k is equal to 3 and so on. Means moves towards the right side. Moves towards the right side. If n plus k, mu of n plus k or mu of t plus a, it is moved towards left side. Delay function is n minus a or n minus k. Advanced function means n plus. Plus means in addition, with actual time it is a 9. In advance, he or she came in 8:30, that is a advanced plus. Delay with the 30 minutes, 9:30. Okay, moves towards right side is a delay, moves towards left side is a advanced signal. The way we can represent in the functional representation, the way we can represent it in the graphical representation, unit step function. Okay. Now with this we can conclude. Tomorrow again you can take the same topic, elementary signals. You can continue the remaining elementary signals, ramp signal, parabolic signal. Sai Teja. Why you are writing? If you want to write, you can write it in your notes, not on my page. Please be careful when I'm taking the class. Sai Teja, I will remember you. Don't worry for that one.
Sir, suddenly touched, sir.
Whatever it is, be careful when the class is going on. Following, my dear students. So any doubt, you can raise your hands. I will explain what are the previous classes also and today's class also. Otherwise, you can end this. Thank you. Thank you, one and all.
Thank you.